Right. Just gonna wait for another 10 seconds or so, and then we'll get the lecture started. Alrighty. So this is the optional lecture. Okay, so far I only have one student in the class. Thank you for being here. Um, so I got some stuff that I want to talk about today. We can start with the technical stuff, stuff that is actually related to CISP 300, or we can start with something that is a little bit broader, um, which has to do with AI and what I kind of discovered from other people, what they think of AI, and also how it might be affecting your future. So how do you want to start? The AI stuff? Okay, so we can go back to the boring stuff a little bit later. Okay, that's not a bad idea. All right, so if that is how we want to do it, okay, which I think is actually a pretty good way to start the class. So I'm going to start with an article that you can go kind of look for if you want to. This particular article was published by PBS, and this is the title: How Artificial Intelligence is Reshaping College for Students and Professors. Okay, it's a pretty long one. I can summarize, okay, instead of just watching the whole thing with you, because if I were to replay the video here, I think YouTube will flag me for copyright infringement, so I'm not gonna do that. But you can search for it. All you need to do is to look for the title with PBS, next to the search words. Okay, just add PBS to it, and there we go. Okay, how artificial intelligence is reshaping college for students and professors. And there's a video here. So, in your leisure, okay, when you have time, okay, I think people should watch this video. Okay, but that's just my opinion. Anyway, um, this is basically the transcript of the video. So if you want to kind of read the whole thing instead of watching a video, this is also something that you can do. I can share this with the class if you guys are interested. So I was able to talk to some pretty high-end people, using AI or utilizing AI in their work over the weekend. These were both people about my age, one slightly younger and one slightly older. When I say older or younger, it's like plus or minus 3 years. Okay, so at my age, it's nothing because we're all basically old people, about to retire. But what we discovered during our conversation is what we might see as the current limitation of AI might not be the actual limitation of AI. So if you think about AI as an iceberg, okay, particularly I'm talking about LLM, large language model, and GPT type of technology. So when you look at it as an iceberg, with icebergs, you see 10% of the entire volume, because when water turns into ice, it forms a crystalline structure, which means it expands by about 10%, and that's why it has buoyancy and it floats. Okay, so the top of the iceberg is typically about 10% of the total volume of the iceberg itself, which means 90% is submerged underwater that we typically cannot see. So, if you think about an iceberg like that, based on the discussion of with these peers of mine, we might actually be only seeing 2 to 3%. Okay, now I just pulled a number out of thin air. Okay, but what we currently see as the limitation of AI may not even be close to the actual limitation of AI that are available today. So I'm not talking about the next 5 years or whatever number of years. I'm talking about the technology Gemini that is now available. So I want to talk about why there's a speculation, okay, and why I think it is well founded as a speculation. Um, AI is trained based on raw data, okay, human data. You have articles that people write, okay, you prove mathematical proofs that people write, and so on. So for the most part, the material was generated by what we call neurotypical people. So have you guys, do you know what I mean by neurotypical? Nope. Nope. Okay. All right. So we'll go take a quick look at what is neurotypical and what is the other side of neurotypical. So neurotypical, and Google does a pretty good job, finding the definition of neurotypical. So, neurotypical describes a brain that develops and functions in a manner considered typical or standard within society, processing information in ways that align with societal norms. Okay, so it really has to do with the norm. Okay, so if you think about everything that you do, how you interact with people, how you read technical stuff like the reading material for this class or reading material for your math classes, and how you spend your time. Do you spend your time thinking? Do you spend your time socializing? If you do watch any type of social media, what type do you watch? Okay, because there's a huge variety. So a neurotypical person means they are quote unquote average. Okay, which is the definition of typical. So AI being trained by material that is mostly created by neurotypical people means that it will model the end user as a neurotypical person, which also means there are limitations that the AI is assuming on the end user. It's like, okay, I want to explain this really complicated concept to you, but as a normal user, as a neurotypical person, I'm going to dumb down the explanation. Okay, I will water down the explanation. I will only explain the parts that I think you can understand to accomplish what you need to do, but I won't go any further than that. So that's a speculation. It is a hypothesis. Okay, it is something that we think that AI is doing, but how about a proof of whether that's actually what it's doing or not? So separately, my friend who is a scientist at Lawrence Livermore National Lab, he did some tests. Okay, he engineered certain types of query and changed the way of the format of the query just to test whether the AI can actually think in ways that are more abstract than he thought AI could be able to do. And his experiment concluded that yes, AI is actually capable of more abstraction than we think that it can do. So separately, I was using a really long conversation in AI on certain types of topics that would not be appropriate for a class. However, I found that AI was able to replicate my writing style and the way that I express ideas, which is mostly by metaphors and paradoxes and analogies. So it was able to copy the way that I write, the way that I think, because it was thinking, okay, with all of these data points in the context window, the best way to describe concepts to this particular user is to make use of metaphors. Okay, and not, I'm guessing not a whole lot of people think in metaphors or kind of use metaphors in their way of thinking, and it would even assess how much I understand science, math, engineering, and so on, and start to use metaphors related to those areas, which you cannot, absolutely cannot assume on an average user. So what does that mean to us, right? So what that means is um, people who are divergent. Okay, so that's the other word here. Okay, so we have neurotypical versus people who are not neurotypical. They're called neurodivergent. So neurodivergent people has quite a few um, definitions. One of them is people who might have autistic spectrum, and they call that a disorder, but that really is not the case. Okay, so ASD or autistic spectrum disorder. Okay, ASD is a ranking system. Um, I think it is misclassifying people because all both of these people that I talked to over the weekend, I would say they are quite divergent. Okay, and they are the kind of people who can discover things Like, they can discover things that neurotypical people cannot. So if you are neurodivergent, okay, which is not a disorder, okay, once again, it is not a disorder. It simply means that your brain does not function like the norm, okay. But in this context, okay, in the context of AI in your career, AI in all of your classes that you need to study, it is actually a strength. I think neurotypical people will have a lot of difficulty finding jobs simply because AI can do everything that a neurotypical person can do, but neuro divergent people is a little bit different, so they can discover things that other people cannot discover about what AI can do. So this is just my spiel about relating Gen AI, generative AI, to what we call neurodivergent. So with neurodivergence, it is also a good time to bring up BA. Yeah, it's BAP. Okay, so BAP stands for broader, um, autism phenotype. So BAP is a subclinical. Okay, so the term subclinical means people who exhibit BAP do not need support. Okay, so they are not like people with ASD level 3 or even level 2, where without support they cannot get on with their daily lives even. Okay, because they cannot talk to people, they cannot really go shopping or anything like that. So BAP is really just a inclination. Okay, it's more like a leaning. um, but if you're curious, I would suggest you to take a look at BAP or BAPQ, which is a questionnaire. It would ask you about certain questions, and depending on your score, it will essentially tell you whether you are a BAP person or not. Okay, and I think knowing that is important. Okay, because knowing that means that you might know this will translate to strengths when it comes to computer science, and also in your near future in terms of academics and also career. So that's all I'm going to talk about in terms of non uh, related stuff to CISP 300. But I think these are long trajectory kind of information that can help you navigate in the next few years at least. Okay, so do we have any questions about what I just said? No questions? Okay, all right. So if there are no questions, I am going to close these tabs here. And if you're interested in this particular transcript, you let me know, okay? But I don't think you need it, okay? Because if you know how to find the original video, you can just kind of watch the video. There we go. So I'm going to close that. And then we're going to go back to, the usual boring stuff. Not so boring, but, to some people it might be boring. All right, so what we'll do, okay, we are recording, very good. So what we'll do today is we are going to take a look at some programs that combines, passing by value versus passing by reference. So we'll go ahead, let me choose a terminal that is of the right size. Okay, let's try this one. I think this one it's not gonna fit. Oh, maybe it does. Okay, so this one does fit. Okay. All right. Oh, before that, one more thing. Okay, so one more thing before that is if you go to the announcement, you know your score already. I think you guys already know your scores. But I have not yet published um, the histogram and also the plot. So this is the histogram of A, B, C, D, F, for exam two by itself. And this is not a very typical curve, okay, because typically I have the majority of people getting a B, possibly spilling over the C. But in this class, the majority of people are getting A's in the second exam after adjustment. And then we have still a pretty high frequency of people getting B's. And then suddenly we have a really sharp dip into the C range, and then it picks up again in the D range. So I don't think anyone who are currently in the class today, like physically, is has anything to worry about. But people who are getting C's and D's in exam two really need to kind of step up in terms of how they study or how much time they invest in studying, or whether they make use of resources like tutors or not. Okay. So this is a curve. I mean, this is a histogram. The curve is right here. Okay, so this shows you, the kind of the number of people getting each kind of score. So we have two people getting, basically every possible points. Okay, and they get more than 4.0 because of the adjustment. And then we have a tie of four people. Okay, four people got identical scores, which is just a tad below the top score, which is 4 points out of 4 points. And then we have a fairly kind of gentle curve, moving down. And then suddenly, right about here, we just see a really kind of sharp dip, down to the end here. Um, it is a curve, okay? You can interpret it any way you want, okay? So this is, I'm not gonna go interpret the curve. I'm just gonna show you the raw data. And I would say anyone who is at least at about this line here, okay, maybe around here, um, they should be okay in the next class. Okay, they're understanding enough of the concepts to move ahead based on exam two. The final exam obviously will be a little bit different, okay, because we'll be talking about function calls, parameters, local variables in the final exam that were completely missing in the second exam. Okay, so that's kind of just a warning, okay? People who are in this region can still struggle a little bit in the final exam, okay? So do not let up, in terms of studying. So there's that. And some people may be wondering, do we have a final exam? And if so, when is the final exam? So I'm going to go to the ARC final exam schedule, okay, which is the source where you get information about when you have a final exam and whether it has a final exam or not. So the final week, starts next Friday. So that means we, including this lecture, we have four lectures, okay? Because we got Monday, Wednesday again. So we got four lectures. I'll use one of them to talk about the exam from last semester. So we're going to use one, and then the other three, we can either talk about homework assignments or concepts, or we can just kind of troubleshoot stuff. All right, so if anything, this is going to be a daytime class. And in terms of the daytime class, this one starts at 9 a.m. on a Wednesday. So the Monday does not apply to us. So we are actually Wednesday only. So we want to see if Wednesday only is listed here. Monday, Tuesday, Monday to Tuesday on a different format, 1 day per week. See instructor for the time and date of the final exam. All right, so with this class, because we only meet technically on a what? On a Wednesday, right? So we technically fall into this category, which means I actually get to decide when the final exam is going to be, and the thing is, we don't have a Monday class using this classroom, which means we can actually take the Monday, Wednesday time slot for this classroom to have our final exam. So that's exactly what I'll do, which means we go back up here and then we look up the Monday, Wednesday time slot for, including 9 a.m. to start with. So that means, we are going to have our final exam in person on the 15th from 8 to 10 a.m. So are we doing okay so far? All right. So I will put this entry into the calendar of the class just so that people can be reminded. So it's the 15th from 8 a.m. Okay, so that's what I'll do. There's a calendar associated with the class, and I strongly recommend everybody to make use of it. Okay, so I will go ahead and show you how to make use of the calendar. So you go to view calendar. I think the student view has about the same thing. And I'll set the schedule first, okay, just so that I don't forget. But then I'll also show you what you can do to make sure that everything on Canvas show up on your phone, show up on your mobile device. All right. So we are going to the 15th, which is here. So I just need to click on it and I go Final Exam CISP 300 and specify the time, which is 8 o'clock a.m. to 10 o'clock a.m. It's not repeating, and we are going to use stamp 306 for that purpose. And then we click Submit. There we go. All right, so now it is scheduled. From your perspective, if you have not done so, okay, you can click on Calendar Feed once you're in the calendar view. And what it does give you is essentially a URL to the actual calendar. You can add this to your, um, I think, and add it to one of your Google account, okay, as a feed. So that will, so this, it will allow your Google Calendar to dynamically update itself based on the calendar events that I put into, this class. The one thing that is not so cool about it is it does not give you per class scoping, which means, once you enable this feature, all of your classes, that have shells in Canvas, all of those homework assignments, all of those exams, and all of those events will show up on your calendar, okay? Which can be a little bit tedious for some people, and then for other people, it's actually a good thing because now you know when which homework assignment is due and when the exams are supposed to be scheduled. So it can be a useful feature, but I'll leave it up to the individuals to decide whether they want to make use of this feature or not. I have that on my phone, so I can actually, start to see. Okay, I'm just gonna give it a try. Okay, I go to December 15th. Okay, and see if that pops up already. So December 15th, it has not popped up yet. Okay, but I think it will start to show in, yeah, at some point in time. But this is I think it's a cool feature. All right, so I'm gonna close this, go back to the class, and then we'll really get into the sample programs that I'm going to talk about today. So I'm gonna go straight back to the class. So everything that I'm going to talk about today is nothing new from the perspective of reading material, but from the perspective of demonstration, they might be new. So basically, everything is a spin-off from the discussion of parameters. Okay, so I'm going to mix and match by reference versus by value parameters. Okay, and there are four combinations. And what we'll do is we're going to write some fairly simple programs to illustrate the point. So let me switch back to my command line here and start to write a program. We'll call this by val. In other words, or can we I'll just call it val. Okay, val dot cpp, because we cannot do certain things in regular C, but C++ allows all of these to be done. All right, so what we'll do is we're going to say um, both of these are going to be void functions, which means they do not return a value. The only side effect is whether they change the parameter or not. So in this case, we have function g. It takes a parameter by value. Okay, we'll just say that it's an integer value. We'll call it int I. And the only thing it's going to do is to say I gets I plus 1. Well, let's make it, yeah, we can make this I plus 1. And then we have a function g, a function f, which also takes a parameter called I. And this one only does it like I gets I plus 10. And now we have main, and main has its own local variable. Well, let's call that x. X starts with a value of 0. And then what we'll do, okay, I forgot one thing. We're going to call g from here. Okay, there we go. That's important. All right, so we're going to call f from main with the parameter of x, and that's all it's going to do. Do we have any questions about the code that we are looking at? Because if we have any questions, that means it's a good time to talk about the code first before we actually start to run it. Do we have any questions? No questions? All right. So let me ask you then. By the time we get to line 15, what is the value of x of main? 0. That is correct. Okay. It remains as a 0 because both of these are passed by value. In other words, when you look at the parameters, do we see an ampersand before the name of the variable of the parameter? Nope. And once again, nope. Okay. So if the answer is no, that means they're passed by value. If you see an ampersand, it is passed by reference. Okay, so both of these are passed by value, and that's why the name of the program is val, because it's passed by value twice. All right, so what we'll do next is to take a look at, okay, what does this code do when we trace it? Okay, so we will do the usual thing, okay, put it on the side, and then we'll start a spreadsheet for today to trace all this code. Okay, this is the first program that we're going to trace today. There will be some more later on. So let me get rid of this and then go back to the shared folder. And then in here, I'm going to create the spreadsheet for today. And we'll just call this, um, hmm, I'm thinking about, nope. Okay, I think I'll do a little bit better. Let me get rid of this first. And instead, I will create it out of a template. So the reason why I'm creating this out of a template is because I have certain scripts in a template, and I think that is going to be useful because I can actually export the trace and put it into um, the lecture notes, okay, the reading material. So that's going to be helpful for everybody. So I think that's going to be a good idea. So I'm going to rename the sheet here to match the name of the program, val, and also to take a snapshot of the program and put it into the spreadsheet itself. Okay, so I'm gonna take a snapshot, the same thing, and this time copy to the clipboard, go back here, and just do a paste over here. All right, so we're gonna do the same thing, comments, which doesn't do a single thing because there are no conditions to evaluate. So there's nothing that we're going to put into comments, but just as a usual thing that we do, I'm just going to put it over there. We have line number, and then the precondition has nothing to say because once again, we have no global variables, so nothing exists at this point before we get into main. And then let me shrink this column because I think we can actually shrink it quite a bit this time. All right, I think that's good enough. All right, so we start with main, okay? We say, okay, it's line 10. We get to line 11. We have a local variable, which means we allocate the leftmost available column, which is column C in this case, label it with the name of the variable x, and say that it starts with an unknown value. So that's what we do on line 11. Okay, so nothing too new over here. And then we get to line 12, which is also really simple because line 13, sorry, line 13, not 12. So line 13 says, okay, we just want to change the value of local variable x of main to be a 0. Okay, well, that's easy. And then we get to line 14. So line 14 is actually important from the purpose of today's lecture. It is really important. The reason why it is really important has to do with what is the actual mechanism of passing x inside the parentheses of line 14 by value to function f as a function being called. Okay, so we'll deal with the easy stuff first, okay, because in this case, we only have to keep track of the return line number because it's not returning a value. There is nothing on line 14 that I have to do once the function returns. So a return line number is going to be sufficient. So we just say, okay, when you're done, go back to line 15. So that's the easy part. The part that needs a little bit more explanation is we also need to allocate a column for the parameter. The name of the parameter is I. Okay, so that's why we label the next available column with an I. So the question now is, what is the mechanism to figure out what go into the cell that is currently highlighted? In the case of a pass by value parameter, which means you don't see an ampersand before the name of the parameter on line 5 in this case, if it is passed by value, then whatever the argument, which is when you have a function call, the expression that specifies the value for the parameter, the argument itself is evaluated as an expression. Okay. In other words, x is evaluated as an expression. Okay, it's no different than x plus 0, the whole thing divided by 1, which is still x, right? So we evaluate x as an expression. So that means we have to retrieve the value of x, which is a 0, evaluate the expression, which is also just 0 because it only mentions x. So the result of the evaluation is put here. So this may look trivial because this is most of the time what we do, but we're going to have to contrast this with the next sample program when we have passed by reference at some point in this program. So now we get into the function. Okay, line 5 doesn't do a single thing, which is fine. Line 6 is going to change. It would say, okay, where's I? I need to add a value of 10 to I. So we look up the rightmost column that is labeled I, which is column E in this point at this point, and then we go like, okay, we are adding 10 to I and then store the result back into I. So we go like, okay, what is 0 plus 10? It is 10. Where am I going to store that? Well, we look up the column E here. It is labeled I. Does it reference some other column? Does it say, wait, 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 don't overwrite me, okay? That's the column that you're supposed to overwrite. It doesn't say anything like that, right? So that means the 10 is overwriting column E and not column C, okay? That is the most important part to remember in this sample program is we are just overwriting column E and say, okay, your new value is 10. And then we move on to line 7. And line 7 is a function call to function G. Okay, so let me move this one over just enough so that we can keep track of everything. All right, so now we have another return line number because function G also does not return a value. There's nothing on line 7 to continue to do once the function is done. So in this case, the return line number is going to be 8, because when it's done, we are done for the entire function call. So once again, now we have to evaluate, okay, what about the parameter? So this is where things get a little bit confusing because the name I, which is the parameter name from the perspective of function G, that is what we put here. Okay. On the other hand, the evaluation of this I on line 7 is going to say, okay, this is treated as an expression because function G also has parameter I not passed by reference. It is also passed by value. So that means this I here is seen as an expression, no different from I plus 0 in parentheses and then the whole thing divided by 1. It is just an expression. It gives you a particular value. In this case, it is 10 because parameter I of function f now has a value of 10. So we're going to put a 10 here too. It is not a reference to any column. It has its own value, or it has its own ability to store a value. So now we continue execution in function G. On line 1, doesn't do a single thing. On line 2, we look up the rightmost column that is labeled I, which is column G in this case. We retrieve the value of 10. We add 1 to 10. It is 11. The big question is, where do we store the 11? Okay, what do you guys think? Where do we store 11 on line 2? Hmm? Column G. Yes, column G is indeed the correct answer. Because if you look up the rightmost column with a name, okay, and you discover that it is not a reference to some other column, that means, oh, we can just store there. Okay. So that means, we just store the 11 over here. And then by the time we get to line 3, which is the end of function G, now we just go like, okay, we are going to deallocate all the columns for this invocation. So that would be both of these columns. Okay, so both of these columns are going to be deallocated. We also have to remember where to return to, which is line 8. So we just kind of do a reference over here, and then we indicate that these columns are now deallocated. So Alt Shift 5 is what I do to do a strikeout. So now we go back to line 8. Okay, line 8 is the end of function f, or the invocation of function f. So it would do the same thing. It's like, okay, we are done. Okay, we are, whatever main wants me to do, I'm done. Okay, which means it's time for me to go back to main. So it would do the same thing. It would take the columns that it allocated, deallocate all of those columns. But before that, we also need to kind of remember, where am I supposed to go next, which is line 15. So that's what happens here. So now we also deallocate both of these columns. Once you deallocate a column, the values associated with that column, they're not exactly gone, but they're not accessible anymore. So if you ask me at this point of time, does column G still have a value of 11? The answer is yes, but you cannot access it anymore. If the question is column E still having a value of 10? The answer is probably yes, okay, but you don't have access to it anymore. So by the time you get to line 15, the value of X has not changed at all. It remains as a 0. So by the time we get to post, which is, after the return 0, we just go like, oh, so nothing, absolutely nothing happened to X. Are we good with this? Okay, all right. So if we're good with this, there are things that we can do in the debugger just to kind of show how this works, to make sure that we understand this is exactly the behavior of this program. So that's what I'll do. Okay, I'm going to compile the program, val dot cpp, compiled it, and then gdb val, and we'll put a breakpoint on line 7, put a breakpoint on line 13, and put a breakpoint on line, I suppose, 14. Okay, so there we go. So run the program. We are now on line 13. Single step through it. Print the value of x in main. It is a 0. No big surprises here. Single step again into function f. So function f says, oh, yes, go ahead. We'll go ahead and change parameter I to 11. Okay, so now we say, okay, what is I? Excuse me, 10. So it says it's 10. And then we continue to function g, single step through the I gets I plus 1. So this I should now be 11. So no big surprises here. So now we take a step back, continue. So it's now going back to function f at this point. And then if we are to ask what is I in function f, it is still 10. Okay, so this is reflecting that the trace we did earlier is consistent with the behavior of the code in GDB. And if we single step one more time to main, and then we ask what is happening to x, x is still a 0. So GDB is confirming everything that we did with the trace. Okay, not nice to look at, when you're in GDB, but it is demonstrating that everything that we talked about up to this point is consistent with the actual behavior of the program. Do we have any questions before we move on? No questions? All right. So if there are no questions, I'm going to copy valval.cpp to, let me see, maybe valref.cpp. Okay. And then we'll change the program just a little bit. Okay. So we are only changing G so that this one is now passed by reference. That's the only change we're making. Are we doing okay so far? Okay. So this means parameter I of function g is passed by reference, but parameter I of f is still being passed by value. So we're going to take a look at the interaction, because the confusing part is What do we do on line 7? Because line 7 is the focus here is, okay, I have a parameter that is passed to me by value, but I'm supposed to pass it by reference to somebody else. So what should I be doing on line 7? So the focus is more on line 7 than anywhere else with this program. So we'll do the usual thing. Okay, we're gonna have to do this twice. One to put it into the clipboard and one to open up in the program. So we'll put it into the clipboard first, keep it in the clipboard, and then we'll open it again just so that we can kind of view this on the side. I guess we don't really need to do that. Yeah, let's not do that. Let's just cancel here. Go back to the spreadsheet, okay? And plus this one is going to be called val ref, okay? To match the program. And I'm going to put the code here. Okay, we'll need the same number of columns. So column E would be the last column. Maybe not one more. There we go. All right, so same thing. Comments is not going to be useful at all because we don't have any conditions to evaluate. But as a convention, I just put it here. And line number is going to be here. And we have the precondition, nothing to say. We start with line 10. Then we move on to line 11. So this part has not changed at all. So we are not changing anything initially until we get to line 7. So for this part, I'm just going to do really quick. On line 13, x gets a value of 0. On line 14, we do a function call. So this function call is not changed, okay, because function f still has parameter I being passed up by value. So this part has not changed. We have a return line number to line 15, and then we also have parameter I being passed the value of the expression x, which is a 0. So this part has not changed. There we go. And then we get to the function f, okay? Line 5 doesn't do a single thing. Line 6 still does the same thing that it did before, which means your column E is now updated to a value of 10, okay? And now we get to line 7, which is the big question here, is what do we do on line 7? So let me make one more column available over here. The return line number part is not changed, okay? So we still have to specify the return line number is line 8. That part has not changed. We still have to reserve a column with the name of the parameter specified by G, which is on line 1. It is still having a name of I. But now, what we put here is important, okay? We are executing line 7. Now, because this time function G is having parameter I passed by reference. So the caller on line 7 now has to say, oh, okay, I is supposed to be passed by reference. In other words, I need to figure out where I is, okay, which column does this I reside in, and then I need to tell the function being called, which is function G, where to find I, okay? So this time I'm passing I as a reference to whatever column this I on line 7 is referencing. So this time it will be looking at column E because by the time I execute line 7, this I is still referencing the rightmost column available at that point that is labeled I, which is this one here. So it is column E. So now we just say this is a reference to column E. This is the difference, okay? This is the main difference between this program and the one before. And I'm going to even highlight this, okay, just so that people do not accidentally miss that part, okay? I'm going to highlight it with a reddish kind of font, okay? There we go. So by the time we get to function G, okay, by the time we get to line 1, doesn't do a single thing, we get to line 2. So line 2 is now asking, um, where is I, okay? What is I? We are still looking at the rightmost column that is labeled I, which is column G. But when we look at what is in column G, we don't find a value, okay? Instead, we find a reference. We find a way to figure out, okay, where am I supposed to look? So it references column E. Column E currently has a value of 10. So that means this is referring to this value here. And then we go like, what are we supposed to do with it? Let's just add 1 to it. Okay, 10 plus 1 is 11. Where am I supposed to store that? Okay, because when I appears on the left-hand side of the assignment, we now have to decide, are we going to change this column to 11, or are we changing the column that is referencing to 11? The answer is we change what it is referencing. So that means column E is the one that is now updated to 11. Okay, so I'm going to highlight this one with a different color too, okay, just so that people understand, the significance of this particular sample program. And then after that, on line 3, there's nothing else to do. So I'm going to do the same deallocation as before. Okay, so the same kind of deallocation, both the return line number column and also the parameter are deallocated. And before that, we also have to kind of remember where we need to go next. Okay, so this part does not seem to have changed, but it really is significant. Control Alt Shift 5, there we go. So the significance here is when we deallocate column G, we are not deallocating the value of 11 because we are only removing or deleting or deallocating, however you want to put it, a way to find column E. That's all we are losing. We're not losing the result of 11 because the result of 11 is actually now reflected in column E. Are we okay with that concept? Okay, all right. So the rest of this program is pretty much the same as before. So on line 8, okay, we're supposed to, conclude the invocation of function f. So whatever function f has allocated, or whatever the invocation has allocated, they are now deallocated, and this is when we lose the 11. Okay, so let me finish this first. And by deallocating column D and E at this point, this is when the result of 11 is lost. So that means by the time we get back to line 15 in main, variable x of main has not changed. It remains as a 0 the entire time. And then we get to post. All right, so that's the conclusion of this particular trace. So what we'll do next is to use GDB to observe this in GDB, okay? Because I think it's really important that we, I mean, from your perspective, I know, using GDB itself is complicated. I don't need you to know how to use GDB. I just need you to understand what I'm trying to prove in GDB. So we switch back to, GDB, the command line interface here. And then we'll go ahead and compile the code pretty much the same way with a different name, valref.cpp, gdb valref, and basically do the same thing. Okay, we just need to put a breakpoint on line 14. That's all we need. We can single step through the rest of the program. So we run, we get to line 14. We say, okay, what is the value of x? It is a 0, kind of as expected. We single step to valref, okay, and then we single step through this line here. If we ask what is I, it would just go like, it is 10. But you have no idea whether this is 10 is in its own column or whether it is the same column as local variable x of main. Okay, so I can talk about the technique to show you, whether x of main has changed or not, but I'm not going to do it because function g is going to have some really funny stuff to do too. So we're going to single step and call function g with parameter I of f serving as a pass by reference argument. So now we are in function uh, G, and you can see how I is displayed differently too. Because when we call f, it says, oh, I just has a value of 0. Okay, that's not difficult. But when we call G from f, the way parameter I is described is entirely different. Okay, you can see how it's using the add symbol here to basically say, oh, this parameter I is not a value itself. Okay, it is a reference to blah, 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 blah. Okay, now, do we really have to understand what the blah, 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 blah is, that ends with DD0C? Not yet. Okay, the next time you see something like this, it's going to be in CISP 310. Okay, the computer architecture class with assembly language programming. That's that's when I will come back and look at the same concept, but using a different lens to look at this. Okay. All right. So now we ask, okay, single step, okay, and we ask, what is I? I is 11. But this I is a reference, which means based on the trace that we have done, parameter I of f should also be 11 at this point. So the question is, can we verify that? The answer is actually we can. Okay, so there's a feature in GDB called backtrace, BT for stand for backtrace. So what it would do is basically to show you where we are at this point. So pound zero, which is also known as frame zero, is telling you where we are at this point. Pound one, which is also called frame one, is the previous frame, which is the previous invocation. What got me here to begin with? And then frame two would be two invocations away, which is our main. In other words, GDB keeps track of all of these. Now, from your perspective, you can now say frame one. In other words, I am shifting the way I look at the code into frame one. So when you say print I, it is no longer printing parameter I of G, it is printing parameter I of F. Okay, and it would print 11. So that shows the point that I was trying to make, which is when we updated parameter I of G, we actually ended up updating parameter I of F. Then you guys probably will be asking, what about x of main then? What has it changed? What is the value of x of main? So using the same technique, we can now say, okay, let's shift our perspective to frame two. So frame two, according to this, is from the perspective of main. So now we can ask, what is the value of x? This is local variable x of main, which is column C, in our trace. It is still a 0. Are we doing okay so far? Okay, so the rest of this trace is not going to be any more interesting than the previous one, so I'm not going to finish it. So I just want to, kind of give you enough information to really show that when we update parameter I in G, we ended up updating parameter I of F, but it's not changing local variable x of main in any way. Are we good? Okay, good. Okay, so we are gonna move on to the next program. Okay, so we're gonna copy val again. Okay, val cpp to refval.cpp, and then we'll change that. And this time we're gonna change this I to pass by reference, and see what happens. Okay, so given that we have the other program already, what do you think is going to be the final outcome of this entire program? In other words, by the time we get to line 15, what do we expect local variable x to be? Well, okay, I'll give you three choices. Okay, so these are the only three reasonable choices. I'll give you four choices. Choice number one, x remains as a 0. Choice number one, x is 1. Choice number two, x is 10. Choice number three, x is 11. So which one do you think it is? It is not 0, because in this case, parameter I of f is passed by reference, which means when we change I in function f, it's really changing x of main. So it should be a 10. Then you go like, but why is it not 11? It's not 11 because by the time we call g from f on line 7, that I is passed by value. So that means I'm evaluating I on line 7. It gives me a value. And then parameter I of g is really just that value. It is not a reference back to where I is supposed to be or where to find I. All right, so that's our speculation, and you're gonna give it a try now. Okay, so we'll go ahead and do the same thing. Okay, copy and paste the actual code. So this particular program is going to be quite important, not only from the perspective of the final exam, but also from the perspective of what you need to know when you move on to CISP 360. So now we go with the ref val, okay, rev val, and paste the actual code over here. Okay, I could have just copy and pasted the structure of the columns, but that's okay. That doesn't take too much time. Line number. Um, Nothing to say in the precondition. We get to line 10, get to line 11. Nothing has changed here. Okay, all of these are the same. So I'm going to speed right past all of these things until we get to line 14. So when we get to line 14, several things have to change. The first one is not changed. Okay, the return line number is still going to be line 15. That's the easy part. But what we're going to use, what column E is going to do is different. It is still labeled I, because we are still looking at the name I, which is the parameter of function f. Okay, so that is still labeled I. But when you look at function f, I is passed by reference. So that means when we look at the argument x, we're not going to say, hey, this is an expression. Let's evaluate the value of the expression. Whatever that turns out to be, we want column E to be the value of the expression. That's not what we are doing anymore because it's passed by reference. So when it is passed by reference, the compiler or the computer will basically look at line 14 and say, hey, whatever is taking the place of parameter I, better have a place to store it, to store its own, to store its value. So now we ask, okay, is X a place where I can change something? The answer is yes, because X is column C, it has a column, so we can store something, we can overwrite that column. So that's why in this case, this is a reference to column C. Okay, that's the change in this case. So we're going to take a look at the impact of this seemingly minor change compared to the previous two programs that we have looked at. So now we continue execution in function f. Okay, so we get to line 6. So line 6 is now different because line 6 is saying, okay, where should I find the value I? So we look up the rightmost column, which is column E that has a label I. It says, hey, don't look at me. Okay, I don't have a value for you. I only can tell you that you're supposed to look at column C. So column C says, okay, I do have a value. It is 0. So that 0 goes here. 0 plus 10 is 10. Then we have to decide where are we supposed to store the 10? Because column E, which is labeled I, says, don't look at me, okay? Don't update me. Do not look at me for a value. Instead, go to column C. So this is why in this version of the program, column C is the one that is getting the value of 10 right here on line 6. Then we move on to line 7, okay? When we move on to line 7, we have to call function G, which means we need another return line column. It is going back to line 8. Simple stuff, not a big deal. And then we also have to specify. We are supposed to set up a column for parameter I of G. And this time, what are we going to put here? Well, we look at parameter I of G. It does not have an ampersand, which means it is not passed by reference, and instead it is passed by value. So because parameter I of G is passed by value, so that means on line 7, this I is treated like an expression. It is just a usual expression, once again, no different from I plus 1 in parentheses and then the whole thing divided by 1, which is really just saying, oh, okay, we just need to get the value of I and make a copy of that value in column G. So the way it works is this I is referring to column E, which is the rightmost column labeled I at this point. It says, don't look at me, I don't have a value, go look up your column C. Column C says, yeah, I do have a value, it is 10. So that's why we put a 10 over here when we execute line 7. We put a 10 over here. All right, so I'm gonna pause, okay? Do we have a question about why column G has a value of 10 this time? Don't have a question? Okay, so if you don't have a question, that's fine. I'm just going to re-clarify why that is the case because column G is representing parameter I of G. It is not passed by reference, it is passed by value. So that means the value goes to the column itself. It is not a reference to something else. So this time, when we get to function G, we go to line 1, we get to line 2, it says, okay, what is the rightmost column labeled I? It's column G. Then they ask column G, do you have a value? Column G says, yep, I do have a value. It is 10. 10 plus 1 is 11. So the right-hand side of line 2 is still evaluating to line 11, just like the other two programs. The question is, where am I supposed to put it? So once again, I look up the rightmost column that is labeled I, which is column G, and I ask, hey, column G, can you update a value here, or are you a reference to something else? Column G goes like, oh, I store a value. We can just update column G. So that's why column G is the one that is updated to 11. And then by the time we get to line 3, we deallocate all the columns for the invocation of function G. So we do the usual thing. Okay, we copy, paste, and then we strike out. There we go. But this is why we lost the value of 11, because the value of 11 is column G. When you deallocate column G, the value of 11 is gone. So now we go like, okay, where are we supposed to go next? Okay, that's based on the return line number, which is line 8 in this case. So when we get back to line 8, it is also going to deallocate these two columns. Okay, so let me do the deallocation first, and then we'll go back and talk about what is lost in the process. Okay, so one way to think about this is to think about what is lost as we deallocate columns. In this case, on row 15 of the trace, what we lost is column E, okay, along with column D, but column E is the one that is significant. So what we lost is a reference to column C. We did not lose the value of column C because column C is still here. It has a value of 10. It's not lost yet. So now by the time we get to line 15, column C still has a value of 10, but not 11, because the 11 is over here, it is deallocated. So that's how we get to post over here, and that's how this is supposed to work. Do we have a question about this trace, which is rev val? Nope. Okay, so then we are ready for the last one. Okay, so yeah, I think this is perfect timing. So we'll go for the last one, which is ref. Okay, so we'll go copy val.cpp to rev.cpp, change ref.cpp, so that we have both of these passed by reference this time. This is passed by reference, and so is this. Okay, so this one illustrates a point that we have not explored yet, which is from the perspective of function f on line 7. It is now saying, oh, my own parameter I is passed to me by reference. I know where to find that column. But when I need to pass my own parameter I to parameter I of G, what am I supposed to pass? Okay, because that also wants to be passed by reference. So that will be the focus of this particular demonstration is on line 7, what are we supposed to do? So are we okay with that concept? Okay, so let's do it, okay, because once we do it, you will understand, oh, okay, so that's how it's supposed to work. So we'll go take a look at the trace of this code in another sheet. So copy to the clipboard, perfect. And this time I can be a little bit lazy. Okay, we'll try the lazy way of doing this, which is duplicating an entire sheet, change the name, and then just delete the portion that we don't need, and then paste back into stuff that we do need, okay, which is this code here. And then we just go like, okay, we'll just erase everything down here, okay, all the way. And then we just kind of restart things up to from line 14, okay, because everything before line 14 are still exactly the same as before, so we're not going to repeat that. On line 14, okay, we have return line number, which is line 15, same as usual, nothing changed. We go to column I, it's still the change, like it's still the same as the previous one, so this is basically a reference to column C in this case, so that part has not changed. We get to function F on line 5, doesn't do a single thing. We get to line 6, it is updating column C because I is referencing column C, so that part still has not changed. It is line 7 that is the big question. So now the question is, what are we supposed to do on line 7? So now we have to think a little bit more clearly. When we get to line 7, what is it really trying to say? We're supposed to call function G, okay? So we'll go set up things that are easy first. So column, we have to allocate another column for the return line number. Oh, wrong line here. Return line number, it's supposed to go back to line 8. That's the easy part. The labeling of column G is also easy because it is the name of parameter I of function G. Okay, so that's the easy part. So now we have three choices of what to put into this particular cell, which is what? G12. Okay, we can specify the value, which is 10. Okay, we can specify a reference to the reference itself. In other words, we can say reference column E, or we can refer all the way back to column C. So those are the three available choices. We can rule out number one because we can see that parameter I of G is passed by reference, which means it has got to be a reference to something. We just don't know what it is. Okay, so now we go like, okay, so we know this is a reference to some column. So now the question is it supposed to be a reference to column E, which in return is a column to reference C, or are we just going to go, reference column C directly? What do you think? From the efficiency perspective, which one is more efficient? No, referencing column C, okay, not E. Yes, column C. Yep. Okay. So this is a reference to column C. So that's important. Okay. So I'm going to highlight this cell too because this is the whole purpose of this particular program. Okay. Of this particular sample program that's the main difference between this one and the one before. Okay. When you pass a parameter that is passed by reference to you, you just pass that reference along when you need to pass it by reference again to somebody else. Okay, so there's a big important difference here in terms of the end result of the program because by the time we get to function G, line 1 doesn't do a single thing, line 2, okay? So line 2 is now saying, okay, I need to evaluate the right-hand side of the assignment, and it looks up I. The rightmost column labeled I is column G. Column G says, okay, don't look at me. I don't have a value for you. Look to column C. So column C says I have a value of 10. 10 plus 1 is 11. So now we need to determine where to store the 11. Once again, this is I. We look at the rightmost column that is labeled I, which is column G. Column G says, do not overwrite me. Okay, I am just a messenger. Okay, don't kill the messenger. Instead, go do whatever you need to do to column C. So column C is the one that is now updated to 11. That is the most significant difference between this one and the one before. So I'm going to choose the same kind of color. So these two are linked. Okay, this is the reason why this is happening. We get to line 3. So when we get to line 3, we go like, okay, let's go ahead and deallocate these two columns. Okay, copy, paste, and then strike out. And then we get back to line 8, which is the same as before. This part has not changed. The question once again is to ask what is lost when we deallocate the columns. We just lost a reference to column C. Did we lose the value of 11? No, because the value of 11 is actually here. Is that okay? So now we continue execution on line 8, which is the end of the function call of f. So that's pretty much the same thing. We deallocate the two columns responsible for the invocation of f. Copy, paste, strike out, and then we specify we need to go back to line 15. And then once again, the question is, what did we lose? We lost column E, but did we lose the value of 11? Nope, because column E is only a reference to the column that actually has the value of 11. So now we go back to line 15, which is the end of function, the main function. So that's why, in this case, the result of 11 is going all the way back to local variable x of main. As we changed, the value to 11, which is on line 2, okay, when you look at row 14, it changed local variable x directly. And then after line 15, we don't have anything else to say, we just post. All right. So I hope this class, or this lecture helps to clarify the four possible ways of, okay, I have a parameter that is either passed by value or reference to me, and I have to call another function, which is either passing by reference or passing by value. This shows you the four possible ways. These are the only ways you can combine things, right? So I hope this helps to kind of illustrate that, because that's actually really important. Not only, as I said, because of the final exam of this class, but also because in the next class, CISP 360, this is the kind of stuff that you really need to understand. But before I let you guys go, okay, before I end the lecture recording, I think we should probably see something to see what it's going to do. In other words, instead of giving it an x here, I'm going to give it a general expression. Okay, I'm going to say, okay, this is x plus 0, and then the whole thing divided by 1, which is really just the value of x, right? But it is an expression. So the question is, does an expression have a place to store the value? Okay, can I pass this by reference? So that's the question. So let me exit here, and then we'll do the G++ jf-d-o ref, and specify the executable here. And it says, nope, this time can't do that. So it's complaining on line 14 that you cannot bind a non-const L value reference of blah 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 to a R value of type int. So we are not going to talk about what is an L value versus a right R value, but the point is the program does not compile, okay? Because it does not make sense. Whenever you pass something by reference, you better make sure whatever you specify as the argument that matches the by reference parameter is not just a general expression, but it specifies a place where you can store something. It refers to a particular column. Are we good so far? All right. So that's pretty much the end of today's lecture, as usual, because without a whole lot of interaction with the rest of the class, I go a little bit faster. But once again, for people who are listening in, you know, on YouTube, you can always ask questions in my office hour or by email. And then on Wednesday, we are going to kind of talk about this again, but this time we'll kind of add structures to the whole thing. Okay, so we'll kind of mix and match concepts, on Wednesday. All right. So once again, thank you for being here. I'm going to stop the recorder and get this uploaded, and I'll see you on Wednesday. All right. Thank you for being here.